This video is part of the series on the Control101 MATLAB toolbox. Here we're going to focus on first order model behavior and the app files that support that. Some background and context then. So the community has agreed on an outline structure for a Control101 course, and this MATLAB Control101 toolbox has been developed to support that, because MATLAB tools are very good at visualization, doing number crunching and so forth. This video focuses on apps to help with the understanding of first order dynamics. First order dynamics then. So many systems can be represented by a first order differential equation of this form: a dw dt plus bw equals cu, w the state and u an input. And common examples are things like mass damper systems, heating, tank level, car speed, DC servo and so on. Consequently, understanding the essential characteristics and behaviours and modelling of these systems is a core engineering requirement. Some background on first order model behaviours then. You can see with a model like this, you'll get a behaviour a bit like the graph shown on this slide. Now, what are we interested in? What's the impact of the initial condition? We seem to have this monotonic change in gradient tending to 0, but how exactly does it change? And we have a steady state, and we might be interested in what exactly is that steady state. The apps allow users to explore these behaviours and also to practice common modelling techniques. The first app then. So this app allows students to visualize the invariance properties of core intercepts, and you can see I've just marked two of those with those circles, and you'll see one is the intercept of some dashed red lines and one is the intercept of some dashed pink lines, and these intercepts are linked to the steady state and the time constant, and students will need to learn about this. So what can users do? They can vary the ODE parameters, the initial condition, and observe the core invariance properties. Let's do a live demonstration then. So if we bring the app across, I've already opened this, there's the app, and you can see I can change things like the time constant, the gain, and the initial condition. Let's do the initial condition first. And what you see is, as I change the initial condition, that's where the system starts, what you'll see is the invariance points still all lie on the curve. I can also change the C parameter, which links to the steady state. And what do you notice? As I change the steady state, it's marked here on the right, as I change it, all these invariance points still lie on the curve. And similarly, I can change the time constant. So that's the time scale down here at the bottom. So as I change the time scale, again, the curve goes through all these invariance points. So these are the sorts of things that a student can investigate with this app. So next app, first order modelling practice. So what we want students to do is to be able to identify the system parameters from a step response, and this app allows them to practice. So what can you see? You'll see you've got sliders in yellow and these pink boxes which allow you to change the time constant and the gain, which are your estimates as a user. What do I think the time constant and the gain are? And then you can use the pink buttons to check your answers. If you want a different example, that's easy enough. You just press the yellow box at the top and you'll get a new example. So again, we'll do a live demonstration. It's a very simple app. So here's the app. You can see it's given us a response here, and it's asking you, what do you think the time constant is? What do you think the estimate is for the steady state gain? So I'm going to put 5 and 6, probably wrong, doesn't matter. Check my estimates. Okay, that's clearly not right. My curve down here has just gone horizontally, in case you hadn't noticed. Let's try 5 and 7. Check my estimates. Well, again, you can see that's not working. Try 5 and 8, check my estimates. Well, it's getting closer. My steady state seems to be about right, but my time constant's not quite right. Let's try 8 and 6. Okay, and now you see I've overlaid with the original response. So I've got the right answer by iteration, not necessarily by understanding. And the idea is that students get it by understanding. So now I could do a new example and try again. So what do I think now? I'll put 2, and I'll put 4. And again, I'm not being particularly careful. And again, you can go through the process. So we've demonstrated how to run and use the first order modelling apps in the Control 101 toolbox. These can be deployed during lectures and student private study to help students appreciate and relate their technical and analytical learning to authentic systems. The manuals contain some MATLAB source code that can be used as templates for students to do individual investigations and modifications beyond that allowed by the apps.